It helps to think of a transistor as your kitchen faucet. A tap can control the flow of water. It can start the flow, stop the flow, and adjust the flow to different levels. In this way, a transistor is similar to a faucet, but instead of controlling the flow of water, a transistor controls the flow of electrical current. This means that transistors have a variety of applications. The two most common applications are transistors as switches and transistors as amplifiers. Using a transistor as a switch is relatively simple. A mechanical switch turns a circuit off by breaking the circuit. A transistor turns a circuit operation off by supplying insufficient current through the base, which stops the flow of collector current. Applying different currents to the base changes the current through the collector and emitter. When the current through the base is insufficient, the collector current is stopped and the circuit cannot operate. This means the transistor is operating in the cutoff region. This is a term that you've probably encountered in your lectures. We'll investigate this in greater detail when we do some measurements later in the lab. For now, it's important to remember that operating in the cutoff region has the same result as if the circuit was broken by opening a switch. The difference is that a transistor takes up less space and doesn't require physical movement. To turn the circuit on, increasing the current through the base will allow current to flow through the collector, completing the circuit and turning it on. This is the fundamental behavior of a transistor. When this happens, the current through the collector and the emitter is enough to power the circuit's components. When this happens, the transistor is operating in the saturation region. In the saturation region, a transistor behaves like a closed switch. Operating in the cutoff region restricts the flow of current, and this will turn a circuit off. Operating in the saturation region allows the flow of current, which turns a circuit on. Switching between the cutoff and saturation regions has the same effect as moving between the open and closed positions of a light switch to turn a ceiling lamp on or off. Up until now, we've been describing the on-off behavior of a transistor used as a switch. A transistor also has the ability to control the flow of current. Controlling the flow of current allows the transistor to operate like a dimmer switch. This is an important ability because many circuits require more functionality than simply on or off. Think back to your kitchen tap. If the options were limited to water is flowing or water is not flowing, the tap wouldn't be as useful to you. You want to be able to adjust the amount of water that comes out of the tap. The same thing is true of circuits. In a transistor, you can change the current through the base, and a corresponding amount of current will flow through the collector. When the base current increases, the collector current increases, and likewise, when the base current decreases, the collector current decreases. The current through the collector can vary greatly, which gives control to whoever is operating the circuit. All this can be done without having to physically move any of the parts on the circuit. When this happens, the transistor is operating as an amplifier. When we use a transistor as an amplifier, the transistor is operating in its active region.